In the ancient past, civilization arose around long rivers that took weeks to travel down. But in the future, we might build civilizations around rivers that were billions of miles long. Ancient Egypt is a fascinating period and place in human history, covering a vast stretch of time and containing immense structures like the pyramids. And yet, as big as the modern nation of Egypt looks on a map, and often might have on an ancient map too, it was a region of civilization almost entirely dominated by the Nile River, and as a result was a skinny realm 500 miles long but only 5 miles wide. It is not alone in that regard either. We see that with other rivers or coastlines, and indeed even with modern roads and freeways in the US, where people will often feel like they're driving by endless houses and commercial centers in some eternal suburban sprawl without realizing that 1,000 feet from that road, the buildings and concrete and landscaping shift into miles of forest or swamp. In today's Nebula exclusive, we're going to be exploring the Topopolis megastructure, one of the biggest buildable under known science and technology, and which has an interesting feature in that it can only be so wide in diameter, but can be any length you wish, indeed billions of miles long if you desire. As a result, you get these long thin habitats, and it would seem almost inevitable you would be running a long river down that body, and roads too of course, and we want to explore that today. Let's begin by explaining why it has those limitations and an open-ended nature. First, the fundamental purpose of a rotating space habitat is to be a ring, torus, or cylinder that emulates gravity by spinning around. We've discussed this a lot on the channel, so we'll keep this abridged, but centrifugal force, especially in large spinning habitats, is effectively identical to gravity. You're not just pinned to the walls or floor like some garment in the spin cycle of your washer. If you jump up, you will come right back down. And this centrifugal force is the same thing making astronauts weightless in space. Since our space station is just a couple hundred miles off the ground, and gravity is barely diminished there, about 90% of Earth normal. Note that astronauts there remain weightless whether touching the station or floating, and on a spin-gravity habitat the same remains true, only reverse. You keep the simulated gravity whether you're touching the spinning structure or not. Indeed, this is why objects further from Earth orbit at slower speeds. They experience less gravity there, and thus don't need as much centrifugal force to counteract that gravity and keep from falling. Being in a wider orbit requires less speed and centrifugal force, which is handy. Unfortunately for spin-gravity habitats, that works against us. Centrifugal force is based on the mass of the object spinning around, times the square of the velocity is whirling around at, and divided by its radius. And by default in a rotating habitat, we want the force to be equal to normal Earth gravity, 9.8 meters per second, or 32 feet per second. That means that if I want to build a habitat twice as wide, but with the same force or gravity, I need its tangential velocity or rim speed to be the square root of 2 higher. Thrice as wide, the square root of 3, 4 times wider, twice the velocity, 9 times wider, thrice the velocity, and so on. The force on that rim, or the outer hull of the habitat, is rising as we make it bigger. More area, more force. But the width of the rim doesn't really matter any more than having 2 rotating rings right next to each other would, or 2 bike tires spinning near each other would, or for that matter a suspension bridge on Earth, which is limited by its length rather than how many lanes of traffic it is wide. It's the circumference of the structure that is adding strain and requiring more tensile force, and you may think of it as a suspension bridge hanging on Earth with a length equal to that circumference, like you cut the ring and laid it out as a long straight bridge on Earth. Fundamentally, any rotating ring or cylinder habitat is structurally the same as building a habitat on a very large and wide suspension bridge on Earth, and thus building a city on a long skinny bridge spanning a very wide gulf is a lot harder and requires a much stronger material than one running down a long but skinny chasm, as if you threw a tarp over the Grand Canyon and built a city on it. From this you would probably conclude we can only build rotating habitats maybe a mile in circumference, but in space there's no wind, floods, or earthquakes rocking, shaking, shoving, or eroding our habitat's exterior, so we can push material limits a lot more, and use even mundane steel or carbon fiber to build a habitat several miles or kilometers in radius that would have tons of dirt and water over every square meter. This is the O'Neill cylinder I so often discuss in our show, or the Island 3 design, 5 miles or 8 kilometers in diameter and 20 miles or 32 kilometers long. And that includes plenty of leeway on the engineering side already, though the design is 50 years old, and if it were built with modern materials would be able to be decently larger. Or you could keep it at 5-mile diameter and go heavier on internal landscaping and redundancy. Whichever the case, I've a fondness for ancient history too, and remember listening to an audiobook on ancient Egypt some years back, where it was describing that land as essentially a civilization 500 miles long but only 5 wide, where that similarity to an O'Neill cylinder struck me, and I've never been able to think of a Topopolis since then without thinking of very long river civilizations. Although amusingly, I tend to think of them in my own head as more in the era of the steamboat or in Louisiana on the Mississippi River, which might have been influenced by both Ian M. Banks' novel Consider Phoebus or the Ravenloft game setting. Whatever the case, if your materials allowed it, you might build that habitat a good deal wider, potentially hundreds of miles wide with something like the McKendree cylinder, but you still hit the limit. Not in length though, and here's the neat thing about them that gets them the nickname of being a spaghetti habitat from some, or why I sometimes compare them to balls of yarn. Any material, no matter how strong, can be bent and tied in knots just fine at a large enough scale. This is why you can use giant steel cables just like rope, though it's easier if it's in strands. Fundamentally, even a rotating habitat, if long enough, could be wrapped around in loops, which means we could loop one around the entire orbit of a star out at Earth or Mars distance and get a hoop 1 billion miles long, 5 or 50 miles wide, and spinning on its axis just fine. But this is the other aspect about rotating habitats folks often miss due to artistic license. We did contemplate putting big windows into things to let natural sunlight in for a lot of earlier designs, and indeed with modern materials those could be as strong as steel, but we usually imagine lighting them from the central axis by artificially generated sunlight nowadays, even if that sunlight might be powered by solar panels outside. As such, we can stick our rotating ring or cylinder inside another thicker, tougher, and vastly cheaper ring or cylinder that was counterspinning much more slowly or not at all, the sheath or superstructure of the habitat. Or for the Topopolis, picture a long wire, conductive metal with a long protective jacket around it, only in this case the metal wire inside is hollow and rotating, probably on bearings or magnetic levitation. And just as you can still loop or twist a hose while it has water going through it, so long as you don't kink it, this habitat can be bent quite a lot and still rotate. And if it is inside a non-rotating sheath like a wire, then we could spool it up like we would a wire spool or like yarn in a big ball. Now you would not want to be making this a big sphere all the way through for heat issues. We usually would imagine wrapping this around an asteroid maybe, or a hoop around a red dwarf, or maybe several winds around that star, giving you a continuous long but skinny habitat hundreds, thousands, or millions of miles long. But you could wrap it a few layers thick into a spherical shell around a star like ours, or bigger, and make a Dyson shell this way that was one long, skinny habitat 5 miles in diameter and several quadrillion miles long, or for a more astronomical context, 1,000 light years long. And you could build something like this as one long line from one star to another, or even between two galaxies if you wanted to. Today we are contemplating an immense world stretching for millions of miles along a single endless river inside a colossal megastructure. In the Big Alien Theory, our Nebula exclusive episode, we explore how the immense resource demands of massive alien species might shape their habitats, civilizations, and the technologies they create. Could the galaxy have worlds that house species whose very size dictates the way they thrive or fail in the cosmos? Join us as we discuss Big Alien Theory, a fascinating exploration of scale, evolution, and civilization exclusively on Nebula. Nebula is the largest creator-owned streaming platform, where every SFIA episode airs early and ad-free, alongside exclusive content from myself and many other amazing creators, like Real Engineering, Real Science, The Science Asylum, Simon Clark, and more. You can also check out our other monthly exclusive episodes. Sign up today at go.nebula.tv/IsaacArthur using the code IsaacArthur to get 40% off an annual plan, making it $3 a month. Nebula also offers lifetime memberships and gift options, so you can share incredible content like the Big Alien Theory with friends and family. Head over to go.nebula.tv/IsaacArthur. And now, let's return to our journey down the vast rivers and civilizations of the Topopolis. And you could build something like this as one long line from one star to another, or even between two galaxies if you wanted to. You'd presumably be needing to have segments constantly being added along the way, as the distance between astronomical objects does change, but that might not be very hard if you were just weaving in a new skinny ring segment, maybe a centimeter across, once a decade every few kilometers, making it no more disruptive than continental drift is, but minus the earthquakes. And you might use this approach even on a much more plausible Topopolis, like one being grown out of an asteroid to wrap around it, or perhaps out of a rocky moon around some ice giant it orbited, as you grew it with the expanding needs of local communities in mind, as an alternative to just adding another whole Island 3 size segment at one of the ends. Here, every parcel of land slowly grows with time. And of course this can be done as sausage links or chain links instead of as a thread, and internally you might drop a mountain range every 100 miles as a natural border and a place you can stick an air wall or emergency bulkhead that can slam down. Though a circular mountain range at the cap of a cylinder segment might look like the voracious teeth of some circle-mouthed predator. Since it is a rotating habitat built in space, you would expect main transport to be by vacuum train in the outer hull, and we have an episode on vacuum trains coming out at the end of February 2024. And if it is all bundled up like a ball of yarn, you can just have coiled segments crisscrossing that the train could cut through. Something about these structures always makes us think to have a primitive civilization inside one. My good friend and best-selling author Dennis E. Taylor did that in his own novel Heaven's River, which is set in a Topopolis, and I did help advise on the structure there, but it already featured a long river and a primitive civilization before I was involved in the project. Great minds think alike maybe, or dream the same dreams, but there is something compelling about them as a quasi-fantasy setting. And indeed, if inside such a place, a train that was able to move between two segments might not just seem fast to those using it, but like it was teleporting, since if we're imagining a map of this place as some big long book of segment after adjoining skinny segment, a point of crisscross might move you from segment 2 to 345, or page 345 on that map. Now, 5 miles wide is an arbitrary figure and an inaccurate one too, because a tube 5 miles in diameter has a circumference of 5 pi, or 15.71 miles, or 25.28 kilometers. I would guess any civilization developing units and measures inside one of these would use their circumference or even intervals of it as their unit of measure, and probably refer to circles as having diameter equal to the circumference divided by pi, rather than as we would usually say it, the diameter times pi, simply from that different perspective of living inside the circumference. We also might imagine our own builders use something decently stronger than steel for their ground, and that resulted in a circumference of an even 50 miles. Let's say for the sake of design, we built one of these as a big single hoop around Saturn, thus we only need one river rather than a second one pumping water back the other way, or some additional tubing doing that. So we run a small, mostly hollow and steep mountain range opposite the river, and put out artificial lighting or fake suns at its various peaks, and everyone uses that mountain range as a page edge on maps, with the river down the middle, itself a mile wide at some points and very slow, and not straight, any more than the mountains, as we can curve it around so as not to be boring. We'll say this Topopolis got built out at the Maxwell gap in Saturn's rings, meaning the hoop of our Maxwell Topopolis was 87,500 kilometers in radius, or 550,000 kilometers in hoop circumference or Topopolis length, or 342,000 miles. If we then portion the whole thing into big square counties, 50 miles or 80 kilometers long too, then you end up with just under 70,000 of them, each the size of Delaware. Though there's nothing stopping some region being the size of Texas, it's just now a river valley running between some mountains 5,400 miles long. And we could easily imagine a civilization running itself just fine at such a length, even a lower tech one than nowadays. Indeed, that's almost exactly half the width and twice the length of Chile. And there's no big neighbors off the side pressuring things, just your neighbors up or down the river, though you could have realms popping up on either side of the river. The whole construct has roughly a tenth the internal area of Earth, though probably at a much higher percentage of land to water, so it would only need to coil around Saturn maybe 3 or 4 times to have an Earth level of land area with a nice mix of lakes and small rivers inside the Topopolis, feeding that massive river over 1,000,000 miles long. Depending on how thick you want your land and shell, you might end up using a whole moon of Saturn to build it, one of the larger ones too, not Titan but maybe Mimas or Tethys. You could add hundreds of more loops by using Titan, maybe even a few thousand. We could even imagine building one right along the moon's orbit around Earth, and at the diameter we discussed, every loop of this Topopolis is giving you an extra Earth's worth of living area. And its outer hull is essentially an orbital ring and launch loop capable of hurling ships out fuel-free at very high speeds, making it not just a big living area but a powerful interplanetary trade hub. Now, back on our Maxwell Topopolis, we might try to imagine a nation a third of 1,000,000 miles long trying to operate without advanced technology, though we should emphasize that there is no reason why they should be, given that they live inside a massive artificial construct. You might plausibly be moving ships down that river at 10 miles per hour day and night, so some province 100,000 miles away facing a rebellion might get reinforcements in 10,000 hours, which is about a year. And honestly would not be nearly the logistical hassle such a distance would normally imply. But in antiquity, some bigger empires did take many months or even a year to move troops around to hotspots. Higher speeds are quite plausible, and the long thin stretch is ideal for operations like mail services, pony express equivalents, messenger stables and inns for switching out fresh horses, and semaphore beacon towers signaling messages with flags of fire. The land itself would seem to favor smaller realms, being long and skinny, but the nature of that land, with the huge passageway, really favors trade and flow of goods and ideas. It's probably insanely fertile land too. Those ancient fertile river valley kingdoms churned out food, and often had population densities only seen away from them in modern times with modern agriculture, but almost all that growing took place close to that river. It's almost unimaginable how much cargo a low-tech civilization could be moving this way, and the whole length is a continuous Nile River or Silk Road when it comes to trade. So it is a strong pump for culture to flow down, and makes a plausible case you might end up with a common trade language down the whole thing. All at the same time, the sheer immensity of scale means someone might begin their life on one part of Maxwell and walk or take a boat for a few hours each day, cover 10 or 20 miles, stop in a new town for an evening to enjoy and learn about it, and it would take a whole lifetime to make that journey. One loop of Maxwell done at 20 miles a day would take you 52 years to complete. And even if your technology allows more, there'd be no real reason to travel faster for personal exploration. And Maxwell is a small Topopolis. Again, we could imagine one made of graphene as wide as any continent, or one that wrapped repeatedly around our own asteroid belt, billions of miles long, or both. And on a place like this, you might have millions of cultures going through thousands of different epochs at a given time. And there are easier ways to combine a lot of living area if you're not fixated on one contiguous chunk of land you can walk, swim, or fly to, so a Topopolis might be favored by those hoping for a more primitivist or vintage civilization. It is interesting contemplating what civilizations on this river might be like too, since there's so many things pushing for both stability and against stability. Every kingdom basically only has 2 borders, up and down river, and those borders never get bigger as your kingdom does since the width never changes. While on a normal 2D surface, your borders get wider as your empire does, twice the width, twice the border to guard. and in 3 dimensions, your imperial blob has surfaces, not lines, for borders, and those rising with the square of your width. In all of those cases, more size means more land in your realm to supply your forces, but your battlefront never rises inside a Topopolis, it merely deepens in terms of how far you need to move troops and supplies, and how large an area you must recruit those troops and draw those supplies from. But it would seem to really favor big defensive bastions, and even more so if you had built a lot of narrow intervals along the way to serve as pressure locks against a breach in a segment, which also allows weather control too. Folks trying to dam or alter that river might be a common cause of war too, and maybe the kind that brought troops in from places so far away you didn't have regular contact with them. Speaking of ways to alter the weather, like raising and dimming light levels along the way, or slightly widening or narrowing the cylinder, I should note that we have some limited options for branching these structures off. It isn't like a water hose or a river where you can just have them meet and split. You basically must widen the segment, which either means lower gravity there or a choppy water environment where smaller ring segments are slowly widening and gaining speed. Then they must match to 2 or more skinnier segments, which themselves would have the same spin rates and gravities. It is a lot easier to do with a water surface instead of land, and thus would have the tributary river look to them, and this really needs to be done inside a wider stationary superstructure, at least for that chunk of it. This is a lot easier if you limit your land bridges to moving down the low-gravity central axis for those splits too. That same approach of widening narrow segments allows you to transit from the inner spinning ring to a stationary superstructure by having a place it widens and where we basically get a staircase of wider ring segments each meeting at a modest velocity difference. Our typical 5-mile wide O'Neill cylinder rotates at 200 meters per second or 440 miles per hour, while our Maxwell Topopolis spins at nearly twice that speed, and some ring staircase of platforms meeting at a speed difference of just 1 mile per hour would be comfortable as steps for us to walk, or as angled platforms with ramps for lips that wheeled vehicles could go down, hundreds of them in a line, possibly more to have an even slower rate. Those might turn and swing backwards like a staircase in a mini-storied building down, or be one big long line. This could be made into some sort of landscape or into a river too. It would seem like a lot of extra effort, but given how much goes into the entire structure to begin with, it might be well within the region of a minor cost gladly incurred for the aesthetics and theme. Though you're also descending to a place with no gravity, or a superstructure spinning maybe just fast enough to give a moon-like low-gravity feeling of there being an actual up and down. This is the main reason why a vacuum train on the superstructure would not have an entrance from every house, whereas normally on a basic rotating habitat with a few meters of hull and dirt between the air and the vacuum outside, every house's basement probably has an airlock to space where they keep their personal spaceship or their pod for getting on the vacuum train line. Once you start wrapping segments of a Topopolis around each other, you must start having your travel and communication lines in that superstructure if you want to take advantage of points of intersection and crisscross. It's an interesting question in the end because any O'Neill cylinder or rotating habitat could be slowly grown in length to become a Topopolis, and I think folks would like the features that let them just keep walking or sailing or flying along without segment breaks. So I think the Topopolis will be fairly common in the future, even if I wouldn't expect many to aim for Dysonian scale just because they can. It is hard to imagine any at that scale losing their technology for the same reason it doesn't work on a Niven-style ring world. You've got technology all over the place to use as examples and to recycle for parts, and you've got a million times the living area all connected, and probably built without pointless wide and non-traversable seas and deserts, in favor of being mostly the sort of land people like to live on. That means if somehow a civilization did go low-tech after some unknown disaster, they have a million times the people, all interconnected, with examples of higher tech all over the place. Restoration and research should move fairly quickly. So good for stories, but not for realistic scenarios. On the other hand, if your typical Topopolis is more modest, something smaller than even Maxwell, which was hardly tiny, then yes, you could have one built with techno-primitivism in mind, or small enough that a recovery was still taking place in a world that, however long, had no more living area than a large state. It's probably still a prime living area with way more fertility and population than we expect a big block of a country to have, but it gets a lot more feasible. It could factionalize into a lot of little kingdoms. Some of these might trade and travel freely, while every dozen or so might be blocked from where the local kingdom just stuck walls and defenses up to not permit trade or travel through, except maybe folks who snuck around some natural barrier like a mountain or scuba dived under a seawall. They certainly seem like great places for stories. Higher tech or lower tech, these things are constructible with no new science, so I think we will see them in the future, where they may be the settings for much of humanity's own continuing story too. But that wraps up our story for today. Thanks again for joining us for another Nebula exclusive.